funniest part about it was Michael Mormon. I don't know if he was in y'all's class that period, but he goes, "Hey, can I ask you a question?" And I was like, "Yeah." And he goes, "Oh, was it Dave?" Okay, I thought it was Michael.
He wasn't in our class, right?
Anyway, he goes, for those who weren't in it, he was like, "So, are our average like, are they done? Are they finished? Is there anything they could change?" And I was like, "Man, no, once it's in the book, it's in the book." He goes, "Okay. Yeah, you did something that boosted our average 5 points." I figured out what it was. It was a scale, like, and this is what happened again this year. And one of my friends, well, it was Reeves in APCALC. She was looking up a student to see how they were doing in the other classes, and she looked them up. She goes, "How does this kid have 112 average in your class?" And what I had done, and you don't know this, but in iNow you can copy. Like if I do like a certain assignment, like for everybody, like a Who Am I paper or something. If I copy it from one class to another class, I don't have to enter all the ingredients. But the way I have this class formatted is different than other classes. Like we don't have a homework section. Everything is just total points. So when I copied something from another class to save time, it introduced a new section. Like, so it basically, instead of having like 100% homework, it did 100% homework. Instead of 100% test, I had 100% test plus 10%. So everything was 110% out of 100. So you put one grade and the average jumped like 25 points. And if they wouldn't have said anything, I probably would have caught that one, but y'all's was much more subtle because I pulled in a different, smaller percentage, but it jumped your grades up. But what it does is it changes the scale on it. And the scale doubled the scale and counted something like a massive bonus.
It was like a 500% off.
Yeah.
It was something
Didn't
nuts.
Hardy, wasn't it Hardy that lost like 5 points on his grade? And like
he was gonna
didn't
take-
say
he took one for the
anything.
team.
Yeah.
He totally took one for the team. Yeah, I wouldn't have been that kind. Anyway, yeah, whatever. I think I got some of it back because I didn't give you bonus points for Vestavia or something. So I got maybe 2.5 points back. It still was a pretty big boost. Oh, and I actually had two people in that class who passed with a 61D for the semester.
Wait.
And I won't say names, but had they not gotten that bonus, they would have both failed that semester.
Oh, like
So-
when he did that?
So quite a help for a couple of people. But anyway, that is neither here nor there. Yeah. Okay, guys. Again, I cannot emphasize enough. Did I start that?
Yes.
Okay. I can't emphasize enough that you need to be doing this work. It frightens me a tiny bit when my highest average performers in the class are the ones asking me questions, and everyone else is not. It brings me a little concern. But if you are figuring it out, awesome. That's great. Again, I can't tell you. Listen, I know life is life. If you were able to make A's without doing all your homework, I understand that. I am no different. You know, I am not going to pay extra taxes when I don't need to. You know, there are certain things where minimum is good. So if you're getting what you want, you're comfortable with that, I understand. But if you want to improve on this test, you definitely want to, at the very minimum, expose yourself to the setup. Because if you can't set the problem up, and actually, listen, every year I have somebody who goes, "I have no idea what this equation is, but I do know the things he's looking for." And they just write a garbage equation and they go, A prime, the area is prime is equal to 0, and it would be maximized because the derivative goes from plus to minus at blank. And they get a couple of points here and there by saying, "Hey, I do know the method." But if you actually know the equations and you can set those up, obviously you're going to get the other 4 or 5. So at the very minimum, expose yourself to the questions. Like, even if you're not going to go through the whole process, you're like, "I got this process down." Make sure that you can actually set up the equations and review each of the problems I'm assigning so it's not a surprise on test day. All right, so let's take a look at some more of these. Again, I'm just do more and more of the same here and try to get you in a really good place. So this was an old AP question. I changed the numbers up, but it was actually an old AP question. It says a rectangle right here, some random one. Now, it doesn't have to be that size. It could be really skinny, really tall, but there's some rectangle that's bounded by the x-axis and a semicircle given by that equation. So this would mean that this is the x and this is the y. Are you with me? Okay, so it says what length and width should that rectangle have so that the area is a maximum? So what's the first thing that should jump out in your head?
Solving for
An area equation. Okay, so I'm going to say area is going to be the thing that's maximized. Area of what? And the area of a rectangle is a what? It's normally length times width. Now, great start, and you probably would have gotten a point for that. Now, unfortunately, L and W, I've got to find a way to get rid of those and work it into this, what I'm given. So the length of this would be that, right? And the width would be that, or vice versa. And how would you determine this length if this is an x and y axis? Now, x, the distance from 0, this is an x movement. That's an x movement. Are you with me? Like if I plug in x equals 3, it's going to give me a y value. If I plug in x equals 2, it's going to give me a y value. If I plug in x equals 5, it's going to land right there because that's the radius of this circle equation. If you might remember that from the basic functions you learned in pre-cal and stuff. So this distance x is, yes, that's part of my length, but what is my length?
2x.
2x, okay? Are you with me? Now you could say, well, that's negative x. Okay, fine. It's double whatever that is. So the length of this is 2x. Now I also need to figure out the width. So what is this width going to be? Now you could say y, because that is definitely the y movement. No matter where it is, it's going to be a y movement, right? So you could say that to start, but again, I have to have those two variables the same. So what's y?
Could you use the radius to find that diagonal and turn it into a triangle?
Could you use the radius, which is 5?
Yeah. And then like set up a
I'm going to use 5, but you tell me what you did. And then I'll,
alright, so you draw the radius as a diagonal on to the corner. And then you do x squared plus
I like your thinking, but I'm going to show you something. You're going to go, you ever watch the old cartoons from like the 60s and 70s where the guy realizes something and he's like, his face turns into a donkey or something like that and he goes,
Is that why the same thing as this?
On this particular one, it looks like it is, but remember that it doesn't have to be this shape. Are you with me?
So it doesn't have to be a square on the other side?
It doesn't have, what's going to end up being that you're going to see because I think, because it's maximized, but just remember, it says we're trying to figure out what shape it is, right? So that's maximized area. So we don't know that 100% right this second, unless you have learned some laws.
Doesn't it have to be though, if it's like.
This is going to be a rectangle.
If it's meeting the semicircle.
Yes, I hear you. All right, but just again, even if you know that, you're still going to have to set up these equations. You're saying x squared plus y squared is 25, right?
Yep.
And then what are you going to solve for?
Y. Well, there we go.
Right? So your thinking's great. It is, and you would have gotten there. But again, if you think about what you want, your length is twice these x's, your height is y, but what is y? What you just discovered, right?
Right.
So once you get it in there, but no, I like your thinking. Once you get it in there, you just have this. Are you seeing that? And now I'm ready to go. So at this point, I'm going to go, well, area is maximized when the derivative, I could say this, area is maximized when the derivative of a is 0, and a prime goes from what? Plus to minus when I graph it. And I'm saying it different ways each time, whatever. This occurs when x equals blank. So if I was using my calculator, I would come over here, pull up this real quickly. Put it over here. So I would turn this thing on. I'm using the Inspire this time. I'll just rotate back and forth. Using my Inspire, I go to this. I'm going to delete all the junk out I have. and I'm gonna type in, first I'm gonna do the area function, 2x times the square root of 25 minus x squared. And I'm gonna graph that. And if I really think about it, what are my lengths of x? What's the biggest and smallest x can be? 5, it could be 5 or it could be 0, it could be the smallest, right? In theory, in between those. So if I'm setting up my window, menu, window settings, I'm gonna go 0 to 5, maybe by ones. And again, it doesn't really matter what my mins are and my max are. I just make them like -3 or 3 or -1 and 1 or whatever, because my goal in the end is to see where it crosses the x-axis. Now I have no idea where the max is on this curve. You can see it's way up, but I don't care, because calculus isn't looking at the actual function, it's looking at the derivative function. So I'm gonna hit tab, and I'm gonna go book button, derivative with respect to x of, book button, derivative with respect to x of vars f1 of x. So when the derivative happens, you're gonna see that derivative cross. It's going from positive to negative, you see that? You're able to see that it's going from a positive value to 0 to a negative. That's what I said, the derivative is 0, and it switched from positive to negative. Where did it occur? And I go in there and I find that 0. So, analyze the graph, menu analyze the graph, you'd be zoom, calculate if you had an 84. I'm gonna find the 0, and it says pick which graph, so I'm gonna pick the red graph, and then left bound, or lower bound, upper bound. So at,
Mine says no 0 found. You can specify that.
yeah, sometimes it does that, it's really annoying. No, sometimes you do it exactly right and it says that.
So should I just plot a y equals 0 curve and then find the intersection?
Between that and this, it might be an idea, I've never thought to do that. What I normally do is just retype it in and it works.
Oh, I don't want to retype it in.
But yes, you might be able to do that, and see. He's saying if you drew a y equals 0, then you could intersect the third curve with the second curve and find it. But hey, just so you know, it will do that every now and then, and I have no idea why. It'll say no 0 found, and you're like, what do you, it's right there, you're staring at it.
No, it worked.
When you did the y-intercept?
Yeah.
I mean, when you did y equals 0?
Yeah.
Yeah, so that's probably a quicker fix. That's clever, that I never thought to do that, but I have noticed that if you retype it in, it tends to work every
Is
time.
it like 11-ish?
I got 3.535.
Guess not. I mean, user error though.
Okay, so guys, I just retyped. If that ever happens, hear me out, and it will occasionally with Inspires. You'll get 0 not found. I don't know why it's gonna. I've seen it happen over and over throughout the year, and there's no rhyme or reason to it. If it happens, retype it in. And in this case, be careful that that's not an ugly equation, because sometimes it's like this long.
I figured out what I did. I put 255 minus x squared.
Oh yeah, that'll do it. Okay, so here we go. So once I have that, I have my intersection. This is what I would do. I go, okay, now I have it. I can come in here and answer this question. 3.535 or 3.536 if I'm rounding to 3 decimals, which is what we do in calculus, in APCALC. So I have that 3.536. And then at this point, I'm going to answer the question, what length and width? So the length is what? 2x. So that's my length. So I would say the length, which is 2x is, and I would take that number, but I'm going to store it to make these equations or calculations easy. I'm going to click on that, and I'm going to go Control Bars A, and I'm going to store it as A. But if you had an Inspire, it would be stored as X. So I'm going to have to come over here and now go 2A equals 7 point. And listen, if you're like, could you just have multiplied that number by 2? You could, but sometimes the decimals are really nasty, and you want to be exact. Like if I had doubled this right here, I would have gotten 7.072. So, and that would be off. If the decimal's off, you miss it. So you really want to be careful about that. So that's my length, and then my width was what? Root 25 minus x squared. And again, this is where I think it's nice. I can just go square root of 25 minus a squared. And if you had an 84, remember, it's already stored, that x value. You could have just done square root of 25 minus x squared. And then for this, I think I got,
You get X.
Yeah, it's just 3.5.
is that right? 3.535?
6. If we're rounding to 3.
If you're rounding, yes.
Is it,
Point
how,
five.
like, much should you round?
You always round to the third decimal place. I guess I gotta be honest with you. AP lets you round or truncate, which means either round correctly like I do, or just chop it after 3. Which I don't know why they do that. It's kind of like in AP physics, you're allowed to use 10 for the acceleration due to negative 10. What's the big deal? Like negative 9.8, you gotta calculate. It's not that big of a deal. But I even asked help. He told me he was letting y'all do that, and I'm like, ouch. Does AP let you do that? He goes, yeah. I'm like, oh, okay. But to me, it seems really odd. Like we had a teacher here once in Algebra 1, and she said, hey, if you ever get 2/3, just put 0.6. And I was like, what? I said, that's so bizarre. I mean, 0.6 is not even the closest decimal. 0.7 is closer. Like, it made no sense why you would even do that. But she was like, it's just easier. I'm like, it's easier not to do math at all. Like, I had no idea why she was doing that. But anyway, I guess AP allows you to do that. So here, on this one, that you could have just chopped it off right there and left the 5, or you can round up to the 6. They will take either. Yes?
The reason that physics AP allows you to use 10 instead of 9.8 is because a lot of those AP questions that use gravity end up having whole number answers, and it's just harder to make a whole number answer if you're using 9.8 instead of 10.
Gotcha. Like for the non-calculator ones?
Yeah.
I got you. Yeah, I figured there was something to make sense of it, because it seemed odd that he would do that, but anyway, I've known him for 20 years. So.
But like getting there, so if you make a math unnecessarily complicated, it
Sure.
just wastes time.
No, I totally get it. Are y'all with me on this? But again, every year I have somebody who finds maximum area, which is awesome that you can do that, but it wasn't asked. So really, when I say make sure you answer the question, that happens more than anything, because people go, oh yeah, he needs to maximize the area. I do want to maximize the area, but the question was, what's the length and the width? So how would they have graded you on this? They would have said, all right, primary equation, secondary. They probably wouldn't have given you 1 and 1. They would have said +1, +1 for finding the correct length and width. They would have said, all right, you're telling me you know that when the derivative is 0 and it changes from plus to minus at that, so now you're at 0.5, 0.6, 6.7 points. That's probably what they would have done. And the only other variation of that is, since I did know that my bounds were 0 and 5 on my x, if you had said, you know what, I'm just going to check my area at 0, at 3.536, and at 5, if you would have checked the max that way, which is fine if you want to do that, instead of giving you these 2 points this way, they would have given you the 2 points that way. Does that make sense? So again, I know a lot of people that they say, you know what, I hate looking for that implied domain there. They would just rather do this. But if you noticed on the homework last night, on 2 questions that I gave you, I said find out where it's maximized, and you went and you did the derivative and you found this value, but at that derivative, that's where it was minimized. But people get kind of cocky and they forget to actually check the derivative curve and see, was it really changing from plus to minus? And on the curve that you had on those homework problems, it wasn't. It was going from negative to positive, which meant it wasn't maximized anywhere. There was just a min there. So you had to check the endpoints to see which one was higher. So be careful about that. Don't just always assume that the critical number you find is going to be your solution. Am I making sense on that? Okay. But you saw that on your curve. You saw that it crossed through from plus to minus, so that gave you that confirmation. So bottom line, don't just write this out of habit. Make sure you're actually checking that. And if it doesn't work out that way, you would have to find the endpoints, because if it's doing this and I'm saying where's it maximized, it would have to be being maximized on one of those ends. Are y'all seeing that? All right, look at the second one. Well, we actually did one like that. Or a little bit like that. We'll do it anyway. Anyway, how about this? So, a rectangular page is to contain, oh no, this is a little different. It's not a box. So a rectangular page, here's my rectangle, is to contain 24 square inches of print. Now, what do you think that means?
Like,
So-
where their arms are 24.
Yeah, so the area where the writing is gonna occur. Like my wife is an artist and she's actually trying to make this book, like this kind of like a coffee table book these days with a lot of her artwork and stuff. And she's trying to format this thing where there's so much writing that she's gonna have in there. And then she's got other stuff, so she needs white space around there. So it is something to be considered. If I want 24 square inches of print, let's just say you determined your font size, it's gonna be great for older people or whatever, and you've got what you want on that page, you're trying to figure out what kind of print that I need, so I get that stuff on there, but still don't have the letters running all the way to the edges, right? So let's just say they determined that this area right here, the 24 square inches, had to have occurred somewhere in this, right in here. It says the margins at the top and the bottom are 1.5. So if there's 1.5, that means this height right here is 1.5. So each of these lengths, 1.5 inches, top and bottom 1.5. But on the sides, this is going to be 1. So each of these lengths is 1 right here. So the question is, what should the dimensions of the entire page be, right? So that I still use the least amount of paper. Because obviously I could have like a receipt, right? You know, I could have like a 4-inch wide thing with 1.5 inches on the top and 1.5 inches on the bottom and 1 inch of writing that's a mile long, you know, or whatever. Or I could have something that's really thin this way with like 1 word per line coming down or whatever. Or I could have something in the middle. So we're trying to actually get our print on there, but still use the least amount of paper, since you're probably getting charged by the square inch for paper or something like that. So what do? What am I trying to do?
Find the area.
So I'm minimizing area, not of this, but of the whole thing. Okay? So how do I find the area of the whole thing? Now obviously you can start with length and width. How are you going to think about this?
X plus 3 and Y plus 3.
Okay, so if you label, depends how you label it actually. I labeled this as, this part is Y, this part is X, and this part is 1.5 and 1.5. So what would my length and width be? I'll call that width. How about this? We'll call this base length, and we'll call this height, this whole thing. So this is one way to do it, base times height. So what would your base be if you were thinking about it this way?
B plus 2.
So my base would be, wait a minute, if the base is the whole thing, it would be Y plus 2. Are y'all with me? Yes? And if you thought about your height as this whole thing, what would the height be?
X plus 3.
X plus 3. But the problem is, this is one way of doing it. So the problem I have now though is I still have X and Y.
X times Y equals 24.
Okay, so since I know that this interior X and this interior, this interior Y and X multiply to give me 24, since I know that, I could solve for Y and use that as a replacement for that. So this is one method that you could use to do this. You all with me? Now every year I have somebody who thinks about this differently, because I'm not always going to give you this picture, right? What I could do is just give you this information and not draw a picture. So every year, this is what I see people do. They go, all right, margins are 1, and all of this, they call all of that Y. This is another option. And they say margins are 1.5. I'm going to call all of that X. This is what they do, and it's just going to be fine. So this is option 1, and this will be option 2. So the other option they do is they go, all right, I know that the area is just X, this whole thing, times Y. Right? If I labeled it this way. And then they go, well, how do I get rid of that Y? And they go, well, the area of this interior is 24, but what is 24 now equal to? 24 is not, it's this part. So if this was X, what is that part right here?
X minus 3.
X minus 3. And what is that part right there? So they come over here and they go, 24 is x minus 3, y minus 2. Well, how would you solve for y so you could replace this? You could divide all that out. So you could divide by x minus 3. That's gone. And then what?
Subtract, add 2.
Add 2. So you would end up with this ugly looking value. But who cares? Take that, plug it in. So your equation could potentially look like this. And I don't care. They're going to work the same with one difference. The whole setup after this, I mean, the setup, now that you have it, you just got to recognize that your x value you get here is going to be different than the x value you get here, right? Because the x value I get here is going to be that entire height. The x value you get on that equation is going to be just that height. But it doesn't matter because when you go back and plug stuff in to solve, you're going to be okay. So right here, let's just say you did this whole problem, you worked it all out, and you got an x value of, I'm trying to think of, I don't even know honestly, because I didn't work it out that way. But hypothetically, let's just say you got some x value here, and the question was, what are the dimensions? So the dimensions here, if you get an x value, the x is the first dimension, right? That's the, what, this way, the height. And then you would plug it back in here to find the y, which would be the base or the width. But if you, whatever you got for x here, what do you do for height? You plug it into there and add 3 to it. And then what do you do for width? You plug it into that, right? 24 over it plus 2 to get the base length. So you just gotta, does that make sense what I'm saying? Yes, no? You gotta make sure you understand what the heck you're doing here. These values stand for bases. So when I solve for x, if I want base, I gotta go here. If I want height, I gotta go here. But on this one, when I solve for x, if I want base, I'm gonna use that. If I want height, I'm gonna use that. So just make sure you understand what this equation actually means. And if I want area, of course, you just plug x back in here and here, or use your equation, your calculator to help yourself out. Any questions so far on this? But regardless of what do I do after this? Once I add this equation, A is maximized right here, and actually A is minimized, least amount, when
A goes from, or
A prime equals 0 and goes from negative to positive. This occurs at x equals blank. You find it? 6. So this occurs at x equals 6 if you're doing this equation, right? And actually, if x equals 6, I think it actually is the same here. Because 24 over 6 is 4 plus 2 is 6. It would be 6 here. I think so actually may be the same either way for x. But anyway, you write that and then you answer the question. But make sure that you're writing those statements out each time. You with me? Okay. There are some homework problems. 1, 2, I guess a couple. But there's a problem I left off from an earlier day, and I wanted to do it. Because it shows up on my test a lot, and people, here it is. So look up back on page 13. Maybe. No. Maybe. Yes. Okay, so it says which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. So anyway, make sure you note that I didn't finish this on the writing, but I just wanted to me it's more important at this point to kind of start talking about the setup because that's where people struggle. Which points on the graph of that are closest to the point of 0, 2? So do you have a visual of what this graph looks like? I mean, you should. It's an upside down problem because of negative x squared. What's the y-intercept? Positive 4, because when x is 0, y is 4. So it's up here, and then if it's right there and it goes down, anybody have an idea where the x-intercepts are? 2 and negative 2? Because if I plug a 0 in for y and factor that, I get 2 minus x, 2 plus x, so 2 and negative 2. So yes, the graph looks something like this. Hopefully you know that, or at least have an idea that it looks something like that. Now, if that's the graph, the point 0, 2 is right here. So I'm asking you, which points on the graph of this are closest to 0, 2? Now, if you kind of eyeball it, it would be, you think straight line from there to there, it's going to be something like that point right there and that point right there. But I have no idea what that is. Are y'all seeing that? So, ask yourself the question. We are doing a optimization problem where I'm trying to find the closest point. So what do you think I'm trying to do then? Minimize distance. So when I think distance, what should pop into your head? The distance formula. And I'm really doing the distance between this point and this point, aren't I? Does that make sense? Now, if it didn't make sense before, hopefully it does now. So if I ask you that again, just make sure you remember, I am minimizing distance. And I have a distance formula between 2 points. It is what? X minus x squared plus y minus y squared. And I know one of the points is 0, 2. So that can go in pretty easily. 0, 2. But alas, I'm still stuck with y. Man. Only y was equal to something. Help me out. And just like before, it is. Right? So again, use the information they give you. Sometimes I give you information about area and volume and you use that. But if you need a y and they gave you a y, plug that in there. So this is I end up with just x squared there, but I end up with 4 minus x squared minus 2 squared there. Now listen, I can go and simplify that if I want, but if this is a calculator problem, do I really need to? Now if you want to, knock yourself out. You end up getting 2 minus x squared squared. But don't go FOIL that and do all that stuff. You're just giving yourself one more opportunity to miss this. So at this point, once you have this all in terms of one variable, what can you do? D is what? The distance between the points is minimized when? When the derivative of D is 0 and what? Goes from negative to positive. This occurs at x equal, I don't know, I'm about to find out. I'll use the 84 this time. So on the 84, all right, so I'm going to go standard zoom just to start out. Hey, is there a distance I can make my x between? I mean, look at that. This is 2, right? That's less than 2, so I'm going to go like 0 to 2, just eyeballing it. Those aren't my upper and lower values, but they're good enough. And if you're wondering, why does it matter? If I don't get a good domain in my window, at least a decent one, it could actually cross other places. You don't know what the graph looks like. There are times when you don't pick the right window, and there'll be 3 mins there. And you're like, what do I do? Well, you pick the right window, and it tells you which min to look at. So try to get I mean, you guys are intelligent people. Use the resources you have and try to figure out at least something. Get it kind of close. Make sure no other extra points come into play. So I'm going to make it just 0 to 2. And like I mentioned earlier, it really doesn't matter what the y's are, as long as they're on either side of the axis, so that I can see where it crosses that x-axis. So I use like -1 and 1, -2 and 2. It doesn't really matter, just something the same on either side. And then I'm going to go graph this equation. And again, I'm going to graph the equation because I'm going to use it to then graph my derivative. So x squared goes in there plus parentheses 4 minus x squared minus 2. And yes, you could have made that 2 minus x squared. All of that ends in also is squared. So that whole thing squared, and you, again, totally 2 minus x squared, that's fine. And I'm gonna not graph this, because I don't wanna take the time. So I'm gonna turn the function off, and what am I gonna graph in the second one? And by the way, does everybody with the 84 know that if I hit enter there, it turns that function off? And you know how slow it graphs? You don't wanna sit there and wait for both of them. So turn that one off, and now I'm gonna do what here? Somebody. Math 8, pulls it up, x, and then what do you get in there? So you go bars, y bars, function, y1, and then don't forget to finish off with x equal x, which you don't have to do the x equal x on the Inspire, but you have to do y of x inside on the Inspire. So you're still kind of doing the same amount of button pushes. And when I hit graph now, I'm not going to see the actual function graph, which is great, and I just see the derivative graph. But at some point, this thing's got to turn around and cross through there if there's going to be a min. And sure enough, the derivative of d was minimized at 0. It went from negative to positive, right? And all I got to do is calculate the 0. What's a left bound? How about 1? What's a right bound? How about 1.5? Guess 1.2. And it spits out that 1.2247. So 1.2247-ish, right? And what did this calculator also do that was nice for me? Stored it as x, so now I can go back and answer the questions. And the question on this was, what points? So I need both the x and the y. So I've got the x coordinate, and I'm gonna round that 1.225, but they would have let you use 1.224 because that would be a truncation, right? They would just chop after the third. So one or the other. And then now I need the y coordinate. Well, what's the y coordinate? People miss all the time and they write distance. I didn't want distance, I wanted the y coordinate. So what is the y coordinate? What's y equal to on your paper?
4
Oh yeah, 4 minus x squared, right? So all I'm gonna do is go back to my calculation and go 4 minus x squared. And if I had an Inspire, I would have probably stored that value as a, and I would have gone 4 minus a squared. But on an 84, that's one advantage you get. It does that for you, and you get 2.5. Now, if you're wondering why that 1 is there, it's because this 84 uses antiquated technology. I mean, this 84 was originally an 83, and before the 83, there was an 82. And that was made in the 1980s, late 80s, early 90s, 29 years ago. Do you know once I downloaded 3 songs to my school computer, and the entire hard drive was full? 3 songs. That's it. I was like, my computer won't operate. We didn't know anything back then. And the person came in and was like, oh my gosh, what's on there? And it was 3 songs that I had students that were in this band. And they're like, hey man, we're going to send you. And they were WAV files, and they were massive. And our computer storage was so minimal. I mean, like a terabyte? Oh my God, it's unheard of. I didn't even know it was named back then, hardly. I mean, it was like, yeah, I got 200 megabytes as a hard drive. I mean, it was so minimal. But anyway, point is, this kind of stuff is due to antiquated technology. It probably says 2.5 on an Inspire. But it might not. Sometimes that gives you weird values too, but it doesn't ever really matter if you're running to 3 decimals. No. So whether it does or doesn't, AP always makes their questions so that those kinds of errors on calculators don't affect you. You with me? So that's 1 point, and then what would the other point be? Because you got x equals 1.22, but let's use our common sense. What's that? Yeah, so plus or minus on that x if you're really being careful. Not too bad? Hey, anybody have a, yeah. I think we're gonna have one of those today, the first one of the year. Anybody have a question on any homework problem they want me to look at, talk about, discuss, get set up? Yeah.
I think there was one more problem earlier. You did all the work, but you didn't answer the question to us.
Yeah, that happens. If that happens, send me a text so I can fix it. I do it all the time. And you're seeing what I've done. I'm telling you that's why I put it on my list. Don't forget to answer the question. I've done it a zillion times. You get so caught up in the calculus and what you're doing, forget to go back and look and answer the actual question that's being asked. It's really a shockingly common answer. And if you found one, imagine how many others have been found over the years. There was once, I think I did an entire worksheet, I think I answered the question, I didn't answer the question on all of them. They're like, way to practice what you preach, hurry. But yeah, it happens, so really be careful about that, be intentional. And the more practice you get, you're gonna be better at that. But yeah, if you could text me, that'd be great. Anybody else on any homework? Yes?
For the like first optimization linear, you check whether they're using like the second derivative, and you never like showed us or talked to us about that.
I checked.
Like to check instead of using like EBT or number line analysis, you use the second derivative, and I was so confused.
Hold on. Show, what is this? Which homework? Because some of these keys are really old.
Monday.
This is from Monday. Let me see.
Because of the charm. Yeah.
Yeah, I hope I'm not. I am a little bit better at calculus than the first year I taught it, but some of these keys are still hanging around. So this is from Monday?
Yes.
Okay. So, the homework solutions? Okay, yeah, bring those to my attention and I'll get those fixed. So which one?
It was all of them.
Like, I honestly thought that was like much easier. You just find the second
Yeah,
derivative.
it takes a lot longer.
Yeah, it makes so much more sense. If it's ugly, but like if it's not ugly.
No, or if it isn't actually like the value, like if it just bounces, or what was it called, where it goes like from positive to
Like the
positive
layout?
or whatever. Yeah, layouts.
I did that on everyone.
What's that?
I literally have no memory of this.
I mean, it works.
It works faster.
Well, it works unless you get 0, because what happens on a second derivative equals 0?
No one knows.
It's inconclusive.
Would the AP reader take checking the second derivative instead of the mean value theorem for the?
Yeah, they would have to. That's really funny. See, this is why y'all are a strong class. It really is. Like, I've taught this class for 8 years, and I haven't had anybody bring that up. Like, I must have done this my very first year, and I don't know what made me think this was the best idea. Not a terrible idea. Now, if you're doing it manual, the only problem is sometimes second derivatives can get really nasty.
Yeah.
But if you're doing it with a calculator, I mean, you technically could still do that. Check the second derivative at that point and see if it was positive or negative by graphing the second derivative graph. But I'm not going to say I'm going to endorse this. I think I'm going to go back and read you this key.
Yeah, Mr. Hurry,
Is this the only one I've done this on?
I don't know,
The
but
fact that it's black and white tells me a lot.
on like, this one I got like, this should both be going up. So how would that be a minimum?
On which one?
Number 2 on this. Yeah, I was so confused, because like, I pulled up the key and I saw it and I was like, I don't know.
This number 2, find 2 positive numbers?
Yeah.
It says when x equals 1, it's a min. What did you find?
We checked it by doing number line analysis.
Yeah.
When you set the left down, you get a negative.
Okay, I'm just gonna make a note to redo this whole key. And then I'll just look at it now, and then I'll be able to answer, because again, this is black and white, it's been a while. So this is the homework optimization.
It's because when you check to the left, that 1 over x squared is always going to be positive.
Yeah.
Redo, and I'm gonna look, you said that was number 2?
Yes.
Number 2?
I was so confused.
I just like.
I just assumed I messed up.
Maybe I'm doing wrong.
Yeah. Hey, let me just say this, guys. I would advise you to do it the way we've been doing it. I'm not gonna make any endorsements since I literally have no working memory of doing this. And this is probably my 10th year teaching this class, so
Maybe you did.
this is probably a really old key. I'm pretty confident that, look, this probably doesn't have a page number at the bottom, which means it wasn't even in a book form by then. And I've been doing the book for a number of years, right? So this wasn't even, this was just a handout back then. So it's still good problems, but I will take a look at those and redo them and have a better key up. If you want to go back and look. All right. So thanks for bringing that to my attention. Yeah, some of these, sadly, I don't have a staff to like redo and proof and do all that kind of stuff. So all these things, and considering my load this year is really kind of killing me. But yeah, I'll redo this. If you find any more weird things like that, let me know. I'm pretty sure that there's not a lot. Was that the first and only one that so far has done that concave up check? Okay. I'm guessing this was like year 1, and I just let it ride. And also you'll notice I didn't show even on this. I guess I did. That would be enough, I guess, because I'm saying, I probably should have said by the second derivative test, because the second derivative is positive, I know that I probably should have said a little more there, but the reader might have bought that if they were looking at that because you did say positive. Yeah, I might have said a little bit more nowadays. All right, guys, hopefully you use this time to catch up a little bit. I have 2 quizzes sitting right here. It's hard to smell with this mask on, but it's possible that it's in the air. So it's coming. Today's Wednesday. The test is next Friday. I think one of them was scheduled. I mean, the test is next Wednesday? What is y'all's test on?
One of them is an tomorrow, actually.
Yeah, both of them are.
Yeah, they were both.
I don't see my sheet, but if I were you, I would be getting prepared.
I'm trying to set my watch. It's messed up.
She's setting it to 60.
Place overall.
It's still messed up.
Akron, 35th place overall at a math tournament.
Oh, snap.
Forgot all about
One more.
these. So maybe I'm gonna have some more. I do have some more. Okay, I'll look at tonight.
Yeah, it's still going.
You got more on your plate these days.
I can point out something now, like, on this PowerPoint very similar to the paper one like that. You found this actual 6 right here. You want it to plug in, you got 9 or 6, and then you plug in 6 here. I think you know.
You're right, that's number what?
That's number 1.
You want to tell me? That sounds familiar. I bet I fixed it and didn't scan it back in.
I analyzed the zeros first about when I did mean a 0. Then I did again, make sure it wasn't just at 1 point. I don't know.
Zero.
I can't believe how tall your sign is.
Well, there's one right there.
Yeah, but the point is not 0.
Oh, you're right. What the heck? Zero. Which graph?
I think she's coming back next
That
week.
graph. Low one?
Because I forgot what she had to do. She's doing something. She's coming here to vote.
Oh, yes,
And then
yes,
she's just
yes.
gonna stay here because like she doesn't want to go back.
Yeah, no, I've talked to her about it.
I'm excited to see her.
I can tell you this, in the past, the way I fixed it is to go back and re-enter
I'm kind of worried.
that. And I don't know why it has worked in the past. I don't know why that's wrong because that looks really good to me.
Yeah.
And I don't know why it's doing what it's telling
It's
that.
not even the graph, it's just like I checked and
I know.
it doesn't do the.
I wish I knew what to tell you on that, except that I have found when I retype, try it, retype it and see what happens.
Jonathan, I'm disappointed. You should be be smart.
Okay. Try doing this without the graph calculator.
That was so easy.
Oh, goodness. Hey, make sure you're turning all that homework in daily to me. We're not going to take it up at the end of the. If you didn't give it to me yesterday, just give it both to me today. But I'm just going to do that rather than have them all turned in on test day. Having them all on test day tends to breed a lot of. I'm always wait the day before the test before I do everything, and sometimes that makes it a little bit too late to get stuff done. So. Hey, at this point, is anybody having any issues with anything we've done? Like square root, did you run into a problem on the homework that gave you trouble? Are you a little confused about why something's happening? I got a couple people that are really, I'm seeing when they turn their homeworks in, their homework pages in, I can see their work, and then in a different pen, I can see them correcting it. And that's a great idea. Sometimes I wish I had more time. I would actually make you do that. Especially if you were struggling, there's probably no greater way to improve your situation than doing that. It's going to be a really long calculus. I never stopped it.